When the first animals were sent into space, the aim was to check whether life could survive in such a hostile environment. Today, decades later, the challenges have changed. It is no longer just a matter of surviving up there, but of understanding whether fundamental biological functions, such as reproduction, can be maintained after a journey away from Earth. If you like this content, do not forget to subscribe and give like. Your support is fundamental to continue sharing interesting information about space exploration and scientific advances. Recently, an experiment led by the Center of Technology and Engineering for Space Use of the Chinese Academy of Sciences has achieved something unprecedented. A mouse that spent 2 weeks in space has given birth to healthy offspring after her return, which represents a crucial step forward in research on reproductive cycles in space. The experiment was carried out on October 31, 2021, when 4 mice were sent to the Chinese space station aboard the Shenzhou 21 spacecraft. For 2 weeks, they lived in a habitat designed to simulate space conditions and returned on November 14th. One of the females gave birth to 9 young, 6 of whom survived, a normal percentage for this species. The welfare of animals during their stay in space was a priority. The team applied environmental engineering and nutritional control to ensure their health. The habitat had lighting and ventilation systems, as well as a balanced diet which allowed mice to adapt to microgravity conditions. However, the mission faced an unexpected challenge. A change in the return schedule caused an extension of the orbital stay of the mice, putting their food reserves at risk. The solution was quick. The ground team opted for soy milk as a temporary substitute for specialized feed, which kept the physiological conditions of the animals stable. In addition to the food challenges, a real-time monitoring system was implemented using artificial intelligence. This system monitored the behavior of mice, which allowed us to anticipate problems and make informed decisions for the welfare of animals during the mission. This experiment goes beyond a simple birth event. Mice are an important model in biomedical research, and what affects them could anticipate what could happen to humans in future space missions. Recent research shows that microgravity and radiation did not prevent key processes such as ovulation and gestation. Although the pregnancy did not occur in space, exposure to orbital factors before childbirth is significant. The absence of visible effects on the offspring opens the door to deeper studies on reproduction in space conditions, which could be key to human colonies on the Moon or Mars. This experiment marks a milestone in space research. Although there have been cases of animals that have had offspring after returning from space, this is the first to be carried out under a controlled protocol and with detailed follow-up. This allows us to consider achievement as a significant advance in reproductive biology in mammals. Scientists now focus on the offspring born, known as space pups. Evaluating their physical development and the possibility of normal reproduction is crucial to validate the viability of reproduction in space conditions. This is just the beginning of a new era in research on life outside the Earth.